Here we are again at the breadboard. As you can see, I did get some wires for the majority of the stuff, but I didn't get enough and they weren't staying in very well for the data connections. So I just used these again for the data connections. But as you can see, we have our voltage controls, our voltage circuits here, and here is our 4116 chip. And I have an LED set up here. This is not something that's required, obviously. You can have it if you want. You don't need to. The red diode and the green diode are going to automatically be on when you start. I'm going to hit reset, and then you can see what's going on here. What's going to happen is while it's testing, the red LED is going to flash, and then when it's done testing, it's either going to be red or green. It'll stay red or green for 6 seconds, and then it'll reset. Green obviously is that the chip is good, and red is bad. That way you will know. If you don't have an LCD, you can tell by the green and red LEDs. So I'm going to go ahead and reset the Arduino here, and there we go. And you see checking block 1, you see the flashing block 2, and block 3 flashing, block 4, and the RAM is good. Now that's just so you don't like blink and miss it, so it gives you a little bit of time to see whether or not it was good or not. And now you can test another one by pressing reset again. So we got everything set up here. I have a project box to put all this stuff in. I do need to make the prototype. I have some boards. This is not all my code. I used a lot of it from this guy here, his code. However, I don't know if any of you have used this or are going to use it, but I can tell you that it did not work for me. And I doubt it will work for you because there were some major errors in it. And this is after he said he had fixed some errors. For some reason in his video, it looks like his RAM tester is working. However, when I tried to run it, it certainly did not work, and there was very good reasons for that, because it was missing some things, and some stuff that was there wasn't supposed to be there, and it wouldn't work. I don't think there's any way this would work. You could probably try to download this if you want and see if it works. I don't think it will. If it does, then please tell me. Please tell me so, because I don't think it would. But anyway, so yeah, I took a lot of the code from this guy, but it took a lot of work. It took me a few hours to figure out why it wouldn't work. This is his schematic, and these are his power circuits. Mine are way different. He's using the MC 3406380, which is fine. But again, I think my way is a lot easier. Don't have to use any math or anything like that. You just put your stuff in and go. These are certainly workable. They're fine, but I prefer my method. I think it's a lot better and a lot cleaner. This, of course, is basically the same, except I have no idea why he hooked up the diodes to D8 and D9 and then used A4 and A5 for data transfer when he could have used any of these digital pins over here. The A4 and A5 is necessary to control the LCD. Now, if you don't want to use an LCD, that's fine. But if you use my code, you're going to be using these digital pins over here, and you can use these analog pins for something else. I don't know what. It's going to be just a really quick overview. So we have the Arduino Nano right here. and it's going to be obviously plugged in with the mini USB. And the 5 volts from the Arduino is going to go into our first ICL 7660 right here, as you can see, right there. And from to pin 8. And then from pin 8 we have our first diode and our second diode. And from pin 2 we have a capacitor. This is the negative side, and going over into where these two diodes connect. And then from the end of these diodes, it's another capacitor going to ground. And before the capacitor, we have our 10 volts out, our double voltage. It doubles our voltage from the Arduino. But also from this chip, we're getting our -5 voltage, and I need to change that. I don't know that. Anyway, to do that, we have a Zener diode going between 5 and 4, and it's going in this direction. And I used a 6 volt just because it's a little bit above the 5 volts. And then from there, you have to also have a capacitor going from 2 to 4, with the negative side of the capacitor going to 4, positive at 2. And then you have basically that's it. And then coming out from pin 5, you have another capacitor going to ground, and then before the capacitor you have your -5 volts out, and that's it. So this is, and then you have to make sure 3 is grounded, and that's it. So from this circuit, from the 10 volts that are coming out here, we have the 10 volts coming in to this second ICL 7660. It's going to pin 8, and we're just doing the exact same thing. The only thing we're doing different is we're not doing the -5 voltage. We're not doing any of this stuff. So over here, we just have our 2 diodes. These are Schottky diodes, by the way. And we're just doing the same thing we did before. We have a capacitor going from 2 to the middle of where these 2 diodes connect. And then from there, we have our capacitor going to ground. For the capacitor, we have 20 volts. It's not going to be 20 volts, it's going to be roughly 18.5 or something like that. But anyway, you need to make sure on this one that you have 3 grounded and 5 grounded. Both those pins need to be grounded. And then we have a 20 volts out here. It's going to our LM7812 voltage regulator. And we just have our smoothing capacitors here, just 0.22 and 0.1. And then, you know, you have our 20 volts in, and we're going to have 12 volts out. That's going to go to our 4116. Right? There's our 12 volts in and our -5. So all of this is basically just the power for the 4116 to power it. And that's it for that. This right here is an LCD display. I used one. You don't have to, because you can also use the LEDs to see whether or not the test worked. But I like the LCDs, and I'm in Peru, and they were really cheap here, so I used one. It was fun. For this, you have to have a PCF8574 module or some other way to use only a couple of pins for the LCD, because you don't have enough pins to drive a whole LCD after you've used everything. So I used a PCF8574. I think they're pretty cheap. I didn't look at the price, but it was pretty cheap, I'm sure. And with that, you just need to have your 5 volts. This connects directly to the LCD, so basically all you need to do is solder this module onto the LCD. And anyway, so you have the 5 volts and ground coming from the Arduino, and also from the Arduino you need pin A4 and A5 for SDA and SCL, and those are those will be marked on the schematic for the Arduino. I don't know if they're on like basic ones, but if you look at the Arduino, you'll see that those pins are what those are, or can be. But in this case, that's what they are going to be. They're going to be the SDA and SCL. So, and then we have our address pins here, basically our address bus to here, and so each one of these pins is on our ZIF socket over here, and these correlate to pins on the Arduino. And we have enable, write enable, and RAS and CAS, and data out and data in, and these correlate to our ZIF socket too, with two pins on our ZIF socket as well. And obviously the RAM chip is going to go into this ZIF socket when you're ready to test. I also added a dip switch. This is again optional. You can totally rely on the tester if you want, but I thought it would be a good idea to be able to turn one of the bus lines off, so at any time, or any one of the bus lines you wanted, so just to test if the tester is working or not. So you could get like positive reading over and over and over again. You might be thinking, man, is this tester working? Well, you can turn off one of the bus lines and see if it's working. If it's not on and it comes back with a good test, then you know there's something wrong. But if you turn off one of the address lines and it comes back as a failed test, then you know it's probably working correctly. So that's why I put that there. And again, it's totally optional. I thought it would be a good idea, and it turns out it is a pretty good idea, I think. And that's it. That's the schematic. I will have a link for it. There will be a link under the video and on the website and things like that. And I also have the Arduino code here, and I think I already went through this in another video, or I recorded something. I don't know if it's been released or not, but in any case, it's fairly straightforward. You can see all of this stuff. It is correlated with the Arduino pins and all that. As far as the LCD stuff here, if you're not going to use an LCD, you can get rid of all of that stuff. Anything that says LCD, you can get rid of. Like this too, wire, and this is this was something you'll have to add. You'll have to find this if you want to use this liquid crystal PC8574. It just saves you time from having to code your own stuff. So I used that, and that's it. And you can see the tests from the finished product. So this is basically everything. And good luck with it. It's not the easiest thing in the world, but it's not too hard either. So this is just the first board of 3 boards that I ended up having to do because I messed up the first 2. And the reason is because the wiring was very difficult to get on to everything and to make them stay. Soldering wouldn't work very well. So what I ended up doing was just using female leads, taking the plastic off and pre-soldering everything, and then putting those leads on, and then putting the shrink coating around them so that in case they touched, and that was it. So once I get it plugged in, okay, 12 volts. Can you see that? Now you can. Yeah, okay. So we got the 12 volt line there. -5. -4.5. Whatever. It works. So I got that done. What we have left to do I had to redo it several times because these wires, trying to, first of all, soldering them was a no-go, so I had to figure out other methods. So, but it's working. So I'm going to put this lid on and we'll check it out. And now we have our working 4166 RAM tester. Let's check it out. As soon as you plug it in, it'll start testing. And that RAM chip is good. And to reset it, you just click that and then put it back. It's testing again. Cool. And now I'll show you what the dip switch does here. So let's just do line 4. Okay, so line 4 is all disconnected now. Now it'll show as bad because line 4 isn't connected. Test failed. Add address 2. Switch this. Let's turn off switch 3. Do it again. Test failed at address 10. Okay, turn it back on. Now all of the address lines are connected. As you can see, it's probably going to work unless one of the blocks ends up being bad, or one of the addresses. There we go. There you have it. Working 4116 RAM tester. Yay. There you have it. I hope you enjoyed the episodes. I hope if you do try to make one of these, you have success. If you have any questions, feel free to email me or leave a comment, and I'll do my best to help you. Take care.